talk about sketching some polar curves by hand, I do want to preface this by saying that this can be a bit tedious, and as such is often on a calculator section of an AP. So we're going to sketch r equals 2 cosine theta using our knowledge of the unit circle. So a thing worth noting here is that the cosine of theta is the x on the unit circle. So I usually call that x sub uc to clarify that I'm not referring to the x coordinate as like x as an angle or anything else. I'm just referring to when I picture the unit circle, that's the x in the unit circle. So remember that when we talked a little bit about how polar coordinates work, right, there r comma theta, right, the theta is the angle you turn to, and then r is how far you walk as a radius from the origin in that direction. If r is negative, you walk backwards. So we're going to walk through the first quadrant. I'm going to actually show you the points, and then after that we'll probably go ahead and just start talking through the points because it's a lot to plot them. So I'm going to pick the angles that I know in the unit circle. Now I did a really bad job of creating a polar graph here, right? So here's my polar graph paper. It's like a bullseye, right? There's a circle of radius 1, there's a circle of radius 2, there's a circle of radius 3. On typical polar graph paper, you'll also see the lines at the traditional unit circle angles that you know. So like pi over 4, the pi over 3 angle, pi over 6 angle rather, and the pi over 3 angle right here, right? Again, not super well drawn, but you get the gist, right? And then you'll see the same three basic angles: the one that is a pi over 3, the one that is a pi over 4, the one that is a pi over 6. If I just put those kind of poorly drawn, but you get the gist, basic spots on my polar graph paper, that's what you're going to see is the pi over 4 and then the pi over 6 and the pi over 3. Okay, so if we go ahead and put some points on here, so what I'm going to do is I'm going to go ahead and list some thetas, right? I'm going to list some thetas, so 0, pi over 6, pi over 4, pi over 3, and pi over 2. So I'm only worried about quadrant 1 for right now. And what I'm going to find is I'm going to find what my r value is at those angles, right? So my r is 2 cosine of whatever my angle theta is. So 2 cosine of 0 should be a 2 times 1 because the cosine of 0 is 1, so that's a 2, right? So that means, well, we'll put that on in a sec. 2 cosine of pi over 6 should be a 2 times a root 3 over 2, so it's just going to be a root 3. Which for our purposes is like 1.7-ish. You don't have to know the exact number, you just need a basic idea. 2 times the cosine of pi over 4 is going to be a 2 times a root 2 over 2, which is just going to be a root 2. That's like 1.4-ish. 2 times the cosine of pi over 3 is 2 times a half, which is a 1. And 2 times the cosine of pi over 2 is 0 because 2 times 0 is 0. Okay, so now let's plot those points and see how it works. So what this is saying is turn to the angle of 0, right? So 0 is our positive x-axis. So facing in this direction at 0 from the origin, face this way, and walk 2 units. So 1, 2, that's my first dot. That dot's taken care of. Now at pi over 6, which is this first dotted line, right, the pi over 6 angle, I'm going to walk out root 3, which is again like 1.7-ish, right? Normally I'd ask you to be slightly more accurate, but here you're not going to be able to graph much better than 1.7, so that means turn to this first angle, this pi over 6, and walk out 1 full circle, which will be the first bullseye, right, the first concentric circle, and then instead of walking all the way to the second one, walk slightly past the halfway mark, right, so that's going to be 1.7, and now that one's taken care of. I know that my root 2 is approximately a 1.4, so the same thing, I'm going to turn to the next hash mark, which is the pi over 4, and I'm going to walk out 1 full unit, and then an additional, I'm going to walk out 1 full unit, and then an additional 0.4, which means just a hair under the halfway mark, right? So now that one's done. At pi over 3, which is the next angle, I'm going to walk out 1 unit, which means just the first of the bullseye circles, right? And then at pi over 2, I'm not going to walk at all, which means I end up here. So what ends up happening is I have a graph that looks like this, right? Now that's my quadrant 1. When we do the next quadrant, we're going to go ahead and just talk through them because it's a little bit, well, actually the next quadrant has negatives, so that's probably a bad idea. I'm going to erase this and I'm going to walk you through the next quadrant. So the next quadrant has negatives, which is going to make a weird thing happen. So when I go to do quadrant 2, right, so my next quadrant, if I go ahead and put my theta and then my r, which was 2 cosine of theta, right, so my next angle is going to be a 2 pi over 3 followed by a 3 pi over 4, and then a 5 pi over 6, and then a pi. And you know what? I might as well keep going a little bit because I have some room, so we'll go to the next one. The next one's a 7 pi over 6, and then one after that is a 5 pi over 4, and after that I have a 4 pi over 3, and we'll land at 3 pi over 2. Again, I did warn you this was a bit tedious. So notice how much we rely on our unit circle knowledge here, right? So 2 times the cosine of 2 pi over 3, well, that's the same as the pi over 3 spot, except because it's to the left of the x-axis, it's going to be negative. So that's going to be a 2 times a negative 1/2, meaning I'm going to get a negative 1, and we'll deal with that in a sec. All of the pi over 4s, so the pi over 4 we saw here was a root 2 over 2. All of those pi over 4s are going to have a cosine of a root 2 over 2. It's just a question of the sign. Because it's the x on the unit circle, anywhere on this side, so basically all of the angles that I just listed here, anywhere over here, we're going to be looking at a negative cosine. So I'm going to get a negative root 2, and then here I'll get a negative root 3. It's the same numerical values I already had. It's that 1.4 and that 1.7. And here I'm going to get a negative 2 because it would be 2 times negative 1. Then I'm going to go back to getting that negative root 3, and then that negative root 2, and then that negative 1, and then I loop back to 0. So now if we deal with these angles, remember how I said that if r is negative, it means walk backwards. So I'm going to face 2 pi over 3. This is 2 pi over 3 right here. I'm going to face this way. Standing at the origin, I'm going to face this way, but instead of walking forward, I'm going to walk backwards. So instead of walking on the 2 pi over 3 line, I'm going to actually walk on the 5 pi over 3 line. And I'm going to walk backwards 1 unit. So that means that this dot is actually going to go right here. So from here, I'm going to this spot, right? At the next spot, which would be 3 pi over 4, right? This pi over 4 right here, I'm going to walk backwards 1.4. So instead of walking on the 3 pi over 4 line, I'm actually going to walk on the 7 pi over 4 line. So I'm going to walk 1.4 backwards. And then on the next one, instead of walking 1.7 this direction, which is the 5 pi over 6, I'm actually going to walk on the 11 pi over 6. So I'm going to walk 1.7, right? And then when I get to pi, so this one's done, and this one's done, and this one's done. When I get to pi, instead of walking in the pi direction 2 units, I'm walking negative 2, which means instead of facing pi and walking forwards, I'm going to face pi and walk backwards 2 units, and you'll see that that lands me right here. So what ends up happening is I get the exact same shape, but below the axis. So what you might find weird about this is you might think, hey, we just did all these angles, all the ones over here, and at no point doing any of these angles did I hit any of the stuff on this side. Like I've just done all of these angles right here, and I didn't hit anything on this side. Again, that's one of the reasons that this is a little bit difficult, and that's one of the reasons I wanted to show you the negatives. Now, if I keep graphing, what's going to happen is I'm going to start to see some repeated sections. So I just landed here, and I'm going to do this part in black. So if I go to 7 pi over 6, which is right here, instead of walking 1.7 this way, I'm supposed to walk backward 1.7. You'll notice I get a point I've already got. So essentially, I'm retracing the curve. It turns out that I've already hit every point on this curve. So if I do 5 pi over 4, I'm facing this direction, right here, and I walk back 1.4 units. Oh, look, that point's also already in the curve. When I face 4 pi over 3, which is here, and walk back 1, oh, look, that point is also already on the curve. And when I face 3 pi over 2 and don't walk at all, that point's also on the curve. So what we're going to see happen when we do quadrant 4, because we haven't yet, is quadrant 4 is going to essentially do exactly what we've already seen. Quadrant 4 is going to retrace these steps, and I'm going to get exactly that shape. So that little sort of elliptical shape, it's not really an ellipse, but that petal, for lack of a better word to call it, is what we're looking at. That is my curve. And that, as I keep going around the unit circle, I'm just going to keep getting that curve over and over again. I'm going to get this red half followed by this blue half, and then the red half and the blue half. So that's our polar curve.